OCR exam paper F325 from June 2011. Okay, the problem is to find out how much copper there is in a sample of brass. We have 2.8 grams of brass and we dissolve it in concentrated nitric acid. Now there will be an excess of acid there which we need to destroy, otherwise it would react with something else, well, potassium iodide further on. Now the best way to actually approach the calculations on these sort of questions is to go to the final results and work backwards. We're told that the resulting mixture is titrated with sodium thiosulfate to estimate the iodine present, and we're told how much of the sodium thiosulfate we used. So what we can do is we can calculate the moles of sodium thiosulfate. Now I don't like this particular font. Let's have moles of thiosulfate is equal to the molarity times the volume. Well, the molarity is 0.1 and the volume is 0.0298. So this comes to 0.00298. Now we can see from our equation here that the moles of iodine is half the moles of thiosulfate. So moles of iodine equals 0.00298 over 2, which is equal to 0.00149 moles. Now this iodine came from a reaction in step 4, so what we need now is we need the equation for the reaction in step 4. And what we've got is we've got copper ions in solution reacting with potassium iodide. So we need the equation for copper ions in solution reacting with potassium iodide, or copper ions Cu2+, I'll format these in a minute, plus iodide ions, I-, make copper 1+ plus iodine, plus I2. Now let's have a look at this. Let's format it to make it pretty first of all. Chemistry is a pretty subject, we have to have pretty equations. Alright, let's get it correct. Now then, we can see from this that the iodine, there's 2 iodine atoms in an iodine molecule, so we need 2I-. The copper changes oxidation state from 2+ to 1+, so it passes 1 electron, whereas the 2 iodines need to lose 2 electrons to get to iodine. So in fact, each copper is required to accept an electron. So we need as many coppers as there are iodines, and so it's a 1-to-1 reaction. Now if we know the moles of iodine then that's formed, which we do here, we can see that the moles of copper was twice as many moles of copper needed to make these moles of iodine. So the moles of copper equals moles of iodine times 2, which is equal to, and we go back to the moles of thiosulfate value. Moles. Okay, so we've got the moles of copper in our solution, but this was moles of copper in 25 ml of the sample. Now this is an easy mistake to make. If we look back here, we took a 25 centimeter cube sample from a 250 centimeter cube solution. So therefore, in 250 ml, there are 0.00298 times 10 equals 0.0298 moles of copper. Okay, we've got the moles of copper, which is a simple job now to get the mass of copper. Mass is equal to moles times the atomic mass, AR, which is equal to 0.0298 times 63.5. We need a calculator for this. 0.0298 times 63.5, and that comes to 1.89. Or 1.892 grams. 1.89 will do. Three significant figures, grams. Okay, so now the percentage by copper in the brass will be the mass calculated of copper divided by the total mass of the brass, which we're told in the question is 2.8 grams, multiplied by 100. So it's 100 times 1.89 over 2.80. And this comes to 67.6%. And that would be our final answer for the percentage of copper. Now let's just have a look at the question. Let's explain the question a little bit. I'm going to run these together, so I've got a few lines of explanation here. What's actually happening? Well, the brass is being dissolved in nitric acid. From these two equations, you can see the first half equation has got 2 electrons, the second half equation has got 1. So we need to multiply all of the second half equation by 2 to get to then before we can combine them. So that means that copper is going to react with 4 nitric acid molecules. Alright, so our equation for the reaction, when we add them together, I'm going to take it out of here and bring it up to here. This is the first process that's going on. Copper plus 4 nitric acids is making copper nitrate plus nitrogen dioxide plus water. But the problem here is there's going to be excess nitric acid that has to be destroyed. If not, the nitric acid itself is going to react with iodide ions, because nitric acid oxidizes iodide. So we've got to get rid of the excess. Now we get rid of the excess by reacting it with sodium carbonate solution. And so we take the nitric acid and react it with sodium carbonate. Now this unfortunately is going to put excess carbonate ions into the system, which are going to react with the copper. They're going to produce a precipitate of copper carbonate. Now this is not a problem, not a huge problem. It just means that some of the copper carbonate is taken out as a solid. Well, we have to recover that and get it back into solution, and so what we do here is we react the copper carbonate at this point. We then react with ethanoic acid to redissolve the copper ions. So we then have the copper ions in solution, and these copper ions can then, because copper ethanoate is soluble, these copper ions can then go on and be analysed by precipitation of the copper 1 iodide and making a solution of iodine. And that is our experiment.